So friends, this video is in continuation of my previous video number 3, in which the atom and nuclei was covered, but due to certain reason I was unable to cover that video completely. So the last thing of that video was about the decay of beta, and that I was going to show you. So now you can see. The last line, it is shown that the neutron of such nuclei are unstable, and that neutron splits into electron and 1h1 and antineutrino, that is the source of energy, and by that way we can say that electrons are emitted in form of beta decay from the nucleus. And another thing, very important thing, is that is in form of a question: what is effect on neutron and proton ratio? What is effect on neutron and proton ratio when alpha is decayed? And similarly, what is effect on neutron and proton ratio when beta is decayed? And this you have to explain with help of example. You can't take any example and you show the decay of alpha, mass number is decreased by 4, atomic number is decreased by 2, and similarly by beta. No, you have to take a specific example, because from all the nuclei, alpha is not decayed, from all the nuclei, beta is not decayed. For this, you have to learn at least one example in each case, one example in alpha decay and one example in beta decay. So I have noted down the examples also. Now see, first example is of decay of alpha, and from uranium thorium is made. So you calculate neutron proton ratio. Initially, in case of uranium, I have written N by P. So initially mass number 238 minus 92 and proton is 92, and similarly after decay, when we have thorium, 234 is the mass number minus 90 atomic number whole upon number of proton. So we are getting 144 upon 19 after decay and 146 upon 92 before decay. So we can say there is increase in neutron proton ratio. Similarly, you can say the decay of beta. Bismuth is the example. Polonium is formed. Neutron proton ratio initially, neutron proton ratio afterwards. So there is decrease. I think it is all right now. Now come to proof of decay equation. It is very important. Proof of decay equation is very important. That is decay rate. The formula is of decay rate. Relation between decay constant and half-life period. Numerical on n upon n naught is equal to 1 by 2 to the power n. It is very important for numerical purpose. And average life is equal to 1 by decay constant. And I have noted down these formulae also. Please, you note it down. Unit of radioactivity, SI unit of radioactivity, that is becquerel. So dN by dt, that is the first step of decay equation. dN by dt is equal to minus lambda n. dN by dt is decay rate. Very simple question may be asked. Half-life period is given. Number of atom at any instant n is given. So calculate decay rate. I am repeating. Half-life period is given. So with help of formula, half-life period is equal to 0.693 upon lambda. You can calculate lambda because half-life period is given, and number of atom at that moment is given. Formula is in front of you. So n is given, simply you can calculate dn by dt, that is decay rate. Another formula, very important formula for numerical point of view, n upon n naught. N upon n naught is equal to 1 by 2 की power n. N is number of half lives. Number of half lives. I am just giving one example in form of numerical. The numerical is, suppose half life period of any element is 60 days. Half life period of any element is 60 days. In how many years or in how many days number of atom left will be 1/4. You are only concerned with number of atom left, not how much decayed. So number of atom left is 1 by 4. Half life period I have said 60 days. So how many days, after how many days it will happen? So n by n naught, you will place 1 by 4 is equal to 1 by 2 to the power n. Alright. So 1 by 4 can be written as 1 by 2 to the power 2. So it has become now 1 by 2 to the power 2 is equal to 1 by 2 to the power n. So n is equal to 2. Small n is equal to 2. Capital T is given 60. Capital T is given 60. So small t is equal to 120 days. So after 120 days, number of atom left will be 1 by 4. In some numerical it is given number of atom decayed is 3 by 4. What I am saying? Number of atom decayed is 3 by 4. So n by n naught is not equal to 3 by 4. If number of atom decayed 3 by 4, the left is 1 minus 3 by 4, that is 1 by 4. I think it is clear now. Average life is equal to 1 by decay constant, and if you are putting the value of decay constant, that is 0.693 upon t half, so you may get average life is equal to t half upon 0.693, that is 1.44 t half. I think this way of learning is very important, is very easy. I think average life is equal to 1.44, approximately 1.5 times, 1.5 गुना. हाफ लाइफ पीरियड का 1.5 गुना एवरेज लाइफ. Alright, so thank you for watching my video. Please like it, subscribe it, and comment is very important. I am eagerly waiting for the comment of the second video that I have not got yet, but the comment of my first video, I have got a lot of response and comments. Number of viewers in my second video is increasing rapidly, but the number of comments are very less. Please comment on my videos, like it, subscribe it, all these for the benefit of children, just to shine the physics. My motive is anyhow the physics must shine. Thank you.